Section 12.6 Cylinders and Quadric Surfaces. Cylinders. So a cylinder is a surface that consists of all lines, that are parallel to a given line and pass through a given plane, just like a normal sort of cylinder. Elliptic curve. An elliptic curve is the graph of the following, where A, B, C, D, E, F, G, H, I, J are members of some field, usually rational field. Ax cubed plus bx squared y plus cxy squared plus dy cubed plus ex squared plus fxy plus gy squared plus hx plus iy plus j is 0. We can simplify this using translations and rotations and write it in the form y squared plus ay equals x cubed plus bx squared plus cxy plus dx plus e, a quadric surface. So quadric surface, well, a quadric surface is the graph of the following, where A, B, C, D, E, F, G, H, I, J are members of some field. Ax squared plus bxy plus cxz plus dy squared plus eyz plus fz squared plus gx plus hy plus iz plus j equals 0. We can simplify this so it's of one of two forms, by using translations and reflections and rotations. X squared plus by squared plus cz squared plus d equals 0, or x squared plus by squared plus cz equals 0. So we have the following. If your equation is of the form x squared over a squared plus y squared over b squared plus z squared over c squared is 1, then it looks like some sort of ellipsoid. So it looks, any way you slice it, it looks like an ellipse. So all traces are ellipses. If a, b, and c are equal, then this ellipsoid is a very special ellipsoid. It's called a sphere. Next, z squared over c squared equals x squared over a squared plus y squared over b squared. Then this will be a cone. Now, of course, so this is a cone where it opens up in the z axis. If instead of having a z squared here, if you had like an x squared over a squared or the y squared over b squared, well, if it was x squared, it would go in the x direction. It would open the x direction. If it was the y squared it was solved for, it opened in the y direction. So horizontal traces or ellipses, the vertical traces in the planes x equals k and y equals k are hyperbolas, so these will be hyperbolas if k is not 0. And it will be lines, pairs of lines, if k is 0. Next, an elliptic paraboloid. So if it's of the form z over c equaling x squared over a squared, y squared over b squared, it'll be some sort of elliptic paraboloid. And of course, it opens up into the z if it's solved for z, into the x if it's solved for x, to the y if it's solved for y. Horizontal traces or ellipses, or ellipses. The vertical traces are parabolas. So one way it's a parabola, the other way it's an ellipse. The variable raised to the first power indicates the axis of the paraboloid. So that's how. So in this case, the axis of the paraboloid is in terms of z. Okay, so now a hyperbolic paraboloid is, well, similar, except you have a minus, this little plus. So z over c equals x squared over a squared minus y squared over b squared. So it looks like some sort of saddle. The hyperbolic traces are hyperbolas. So you have these hyperbolas. Vertical traces are parabolas. So this way is a parabola, here are hyperbolas. If c is less than 0, it looks like this. And if c is greater than 0, it looks like this. So it just goes in the other direction. X squared over a squared plus y squared over b squared minus z squared over c squared equaling 1 looks like a hyperboloid with one sheet. So the horizontal traces are ellipses, the vertical traces are hyperbolas. So I have here these hyperbolas. The axis of symmetry corresponds to the variable whose coefficient is negative. So in this case, the z is negative, so it opens up with respect to the z. Negative x squared over a squared minus y squared over b squared plus z squared over c squared equaling 1. So it's the same thing, except it's the so this will be a hyperboloid with two sheets rather than one sheet. Horizontal traces in z equaling k is an ellipse if k is greater than c or less than negative c. The vertical traces are hyperbolas. The two minus signs indicate the two different sheets. Okay. So let's do an example. On page 880, problems 31 through 38, reduce the equation to one of the standard forms above. Classify the surface and sketch it. X squared minus y squared minus z squared minus 4x minus 2z plus 3 equaling 0. So let's try to complete the square. Let's group x's together, y's together, z's together, and bring the negative 3 to the other side of my equation. So let's complete the square. These are all going to be monic quadratic trinomials. So negative 4 over 2 is negative 2. Squared is 4. So let's add 4 to both sides of my equation. I have, again, a monic quadratic trinomial. 2 divided by 2 is 1. 1 squared is 1. So let me subtract 1 from both sides of my equation. And so this is equal to 0. And so I have x minus 2 squared is equal to y squared plus z plus 1 quantity squared. And so we see that this is a cone. And so the way that the graph looks, well, I have a difficult time drawing a cone other than sort of in the z direction. So let me just draw it as if I just rotated it. So it really should be it should really be x, y, z rather than y, z, x. if I were able to draw this, but this is the best I can do. Okay, so that is it for section 12.6.